Good evening, everyone. Welcome back to another session on retail analytics. In today's session, we will be discussing on decision tree classifier. Okay, so decision tree will be looking at the concept. Okay, and also we look at a model, right? So decision tree is a supervised learning technique. Right? And you will be able to look at regression as well as classification problems. Right? You can solve both regression and classification problems. Right? We are talking about the tree here. Right? You have information gain. Now, what is the information gain that we are talking about? We are looking at a node, okay, in a particular decision tree, right, to do the partition basically, right? So this information gain is a measure for your change in entropy. Okay, right? Now, what is entropy? Entropy is a measure of uncertainty of a random variable, right? The more the entropy level, the more information content you will have, right? We looked at Gini index. We'll also talk about Gini index, right? It is one of the measures, right, which can be misunderstood, right? So first we'll talk about the root node, right, and the leaf node. We'll also talk about pruning, right? Right. So we look at few of the pros. Why do we go with decision tree classification model? One is it is simple to understand, right? It is simple to interpret, right? It can be opted where you have less data. That means minimal data. If you require a minimum simple data, so what happens with other data types is you require the data normalization, right? So what happens here is you create dummy variables and you'll have to deal with the dummy variables needs to be like you will also have to drop these variables, right? You will not have to look at the missing value. Okay. And in decision tree, you will be able to, cope with both categorical data as well as numeric data. Okay. This is when compared to other data, other models. Okay. So when you look at one other models, it is only supporting either of the two variables. Okay. And decision tree will allow you to perform. That is, you can build it and have it perform even on a simple statistical test. Okay, right? So that your model is reliable. Right? So that will let your models be predictive. You can easily, you can predict your decision tree as continuous. Okay. Right, we have spoken about the pros of having or opting for decision tree classifier. Okay, we'll also look at few drawbacks as an disadvantage, right? So when it comes to decision tree, that is decision tree, so there is a bias, okay, that is being created, right? That means few classes might dominate, right? So therefore, the recommendations, that is the recommended balance to your data set, is fitted prior to your decision tree. Right? We have also spoken about how decision tree is one of the preferred models, being it user friendly, that is the easiest one and the most preferred one, right? Meaning it is able to understand, has the ability to be interpreted. So in decision tree, you are able to train the model that you can use to predict the class. Okay. So in decision tree always starts with root. Okay. So here we are talking about the root of the tree. Right. And on comparison, we'll go ahead with the other nodes. Now we'll look at different types of decision tree. Okay. First is the categorical variable decision tree. Right. That means the target variable is your categorical variable, right? And you have continuous variable decision tree, right? Here what is happening, of course, here your decision tree is having a continuous variable, right? Let's say you have a problem at hand where you have these customers, right? And these customers are from your retail store. Okay. So will the customers pay for the product, and will they return? Okay, we are looking at one scenario here. Okay, will they come back for the product after, let's say, they have tested a product as a sample, they have tested on a sample product, we have distributed as a retail owner, certain group of customers have distributed this sample of a new launch. So here we are predicting if that particular customer will return. That means, will he buy that product when it is launched? Will he be able to go for it? Is what we would look at. Right? So what are the factors that you're looking at? So you will have these different features, right? You have customer name, of course, customer name, details like contact details, right? Customer income, right? You want to see if the customer is willing to, or will he be able to will he be able to buy that particular product? Right. If the product is not being bought by these customers, all the samples that were marketed, right, is of no use, right? Ultimately, you want to predict if the customer is returning or not, right? And of course, not just on the customer income, you might also want to predict what sorts of product will the customer be interested in. Right. So these features could be categorical, numerical, right? And we are predicting on continuous variable. Right, we'll look at the decision tree. Okay, we'll look at the aspects in your decision tree. First is the root node. Okay, so the root node is basically representing the entire population or the sample, right? And this particular root node will be divided into two sets. This is again further divided into two sets, right? And then you have something called as split. Okay, so splitting is you're dividing the nodes into the subnodes. Okay, subnodes is what you're looking at, right? And when your subnodes are again split into, it is called as your decision node. right? And then we also have what we call it as terminal node. Right? So in terminal node, these nodes are not getting split. Okay? These remain as is. Okay? And from your decision tree, that is from your decision node, if you just eliminate your sub nodes, right? This process is called pruning. Okay? So just like splitting, right? Here you are splitting the nodes into subsets, that is sub nodes. I'm sorry, sub nodes, right? You can look at in a opposite way, basically, right? And then you, for your decision node, okay, and then you have branch, right? So branch is basically, branch is also called as subtree. Okay, it is a section. Okay, it is one of the branch in your decision tree, entire tree. Okay, now we also have what we call as parent node and child node. Right? So these sub nodes you have, right? These nodes you have initially, these nodes are divided into sub nodes from your parent node, right? So basically, to make it simple, let me put it this way, right? You have a node, right? Your node is divided into sub nodes, right? So these sub nodes are called as parent node of the sub node, right? And these sub nodes are the child nodes of parent nodes. Okay, you might want to get the difference. Okay, so let me quickly give you an illustration. Okay, this is the root node, right? So you are splitting this. So when you split, this becomes your decision node, right? This is one decision node you have. This is another decision node you have. And the sub node for these will be terminal nodes. This will be your terminal nodes, right? And this will be your decision node again. Understand the difference, guys. And this will be your terminal node again. Okay. Terminal node. This will also have a terminal node. So this is a parent node. Okay. This is a parent node of this node and this node. Okay, that is the difference at a high level. Okay. So now we will look at, so we are looking at it as a node of a tree, which is a test, okay, for your features that you have. Right? It is a repetitive process. So this is happening for your subnodes, branches, right? Subtrees as well, right? So initially, the whole training data set is considered to be the root. Right? And features that you have are to be categorical. Right? Right? What happens if you have continuous data type? You'll have to discretize. You're converting them. Right? You have to convert, discretize. You should do a discretization before you come up with a model building phase. Right? And if we talk about the challenges that we have in decision tree, of course, in any model, you will have challenges. If you talk about the challenges, one key challenge is to identify the features, right? When you say identifying the features, it is choosing what are your relevant features or attributes that you need to consider, right? And also looking at other features will also help. Okay. And your decision tree classification is based on your what type is your target variable, right? Right. We also talked about entropy. So entropy is the measure for your randomness in the information that you have provided, that you have been working on, right? So higher the entropy, it is more difficult to draw any kind of insights from it. Ultimately, you need some insights to draw, right? So that becomes difficult if your entropy is high. Right? And if you look at information gain, so information gain will help you, or IG, also called as IG, will help you measure how these variables are separated in the training. Okay, and this is based on the target. Okay, so it is really important to find the right variable. Okay, so the highest information gain, lowest entropy, that is smallest entropy. Right, we can also talk about CART. So what is CART talking about generally? It is classification and regression tree. Right. Right. It is using to calculate the index method. That is Gini index method. Right. This is used to basically split. Okay. Now, how do you deal with variance? We have to deal with variance, right? Right. When it comes to regression, we are not talking about classification. Okay. So if you are having a regression problem in hand and we are looking at the variance, okay, and to split the variance, so obviously lower variance is selected. Right. Now, how do you calculate variance? calculate variance, basically you're saying variance is equal to sigma of x minus x dash whole square by n. So x bar basically is the mean of the values, right? And here x is the actual value and n is the number of values. Now, how do you calculate variance? First, you calculate the variance of each node. Okay. Calculate the variance for each split as well, right? Nodes, right? Each node. So here we are looking at weighted average, okay, of each node variance. Right, we are looking at chi square, right? So we are looking at chi squared automatic interaction detection, that is detector. So this is, we can also talk about that so it is able to find the statistical significance, right? And statistical significance between these subnodes and the parent node. Okay. And this is calculated with the help of sum of squares, right? And the difference that is observed, that is the differences between the observed and expected frequencies of the variable. So here the variable, when I say variable, it is the target variable we are talking about. Okay. So like I said, it works with the categorical data, that is your categorical variable. So what happens is it can perform, basically it can do more than 2 splits. Right? Now we have looked at these so far. How now, what are the challenges that you are looking at? So how do you deal with the overfitting challenge? Right? In decision tree, obviously you will have overfitting challenge. How do you deal with this? Right? So in decision tree, if there is no set amount of decision tree, or if say there is no limit, if there is, if we do not put a limit on the decision tree, we'll get a 100% accuracy, right? And this 100% accuracy is on train data. So what will happen is it will have one leaf for each of the observations that we have, right? So how can you deal with this? To deal with the overfitting issues, you can do a pruning of the decision tree, right? We discussed, right? Pruning is your opposite of splitting your nodes into subnodes, right? Correct? So if you do not deal with this, obviously you will have to look at the overfitting model, and ultimately you will not have the desired accuracy. Of course, the accuracy will be low. Okay. So you, in pruning, what are you doing? You are cutting off the branch node, right? And of course, there's one also you can do random, look at random forest to deal with overfitting issues, right? Okay. Now we'll look at the model. Okay. This is the model on the retail industry in the retail analytics. And this is about the customers of a retail store, right? We are talking about a retail chain, right? Let me pull it quickly. First, I will import the dependencies. I will import pandas as PD and numpy as NP. Okay. Let me run this. Okay. Now I would like to read my data set. Okay. I'm saying df is equal to pd dot read underscore csv, because my data set is in the CSV format. Of course, if I place this path, okay, what I would do is I will quickly go to the path where my data set is saved, right? And then I will have to replace, since I'm using a Windows operating system, I will have to replace this backward slash, which is automatic. I'll have to use manually replace that with forward slash, or I can also go ahead with double backward slash. Both works. Okay, now if I read the file and I execute this, so this is how my data looks like. Okay, so here I'm importing matplotlib.pyplot as PLT. Right? NA values, I'm looking at, I want to know if there are NA values. Okay, and I will drop them. I will write df is equal to df dot drop NA. Okay, now if I run my, so you see the difference. Earlier I got 8,190 rows, and then I've got 2,069 rows, and columns remain the same. So now I want to drop the, I want to see if there are any duplicate values. Okay, see, there are no duplicate values. Okay, since there are no duplicate values, I'm not dropping any. Okay, if there are any duplicate values, then I might want to drop them. Okay, now I will say CORR is equal to df dot CORR basically. So this is the heat map. So it is basically showing the correlation between these values. Okay, it is talking about the collinearity. Okay, now in my variables I have is holiday, and I am converting this particular variable to Boolean. Okay, so you might just ignore this warning. It is not a error. You don't have to worry about this. It is a warning. Okay, right? So this is the histogram that we were looking at. Right? Now let us look at the pair plot. And I'm also dropping the store and date column because they're not really required for you know, basically the analysis. Okay, so this store and date I have removed, and then I have the variable as df1. Okay, so I have these predictors as well as the target variable. Okay, I will also look at the train and test. Okay, I'm also calculating the entropy. Okay, mean imputation, and then I'm predicting the model based on the train data. Okay, so here we have this. So let me run this. Okay, right. So this is how you can deal with decision tree classification. Decision tree classifier. It is a classification model. All right. What you can do is you can import the dependencies at the beginning, or while you're doing, or you can simply put them at the middle. Okay, so since it was taking a lot of time and resources from the local machine, I have used a notebook, Python notebook, for this particular model. Okay, if you have the resources, right, you can still go ahead with Spider. Okay, I will also comfortable with notebook, so I have tried it on Jupyter notebook. It works same with the Google Colab as well. Okay, all right. We'll stop our discussion here for the day, and we'll continue in our next session. Thank you all.